And we're back.
The Road to Code, episode 8.
Are we on episode 8 already? Man, where does time go?
Yeah, this is just a whole lot of learning. Don't
It
even know.
is. How's it going with you with the learning?
I feel like I'm learning a lot, definitely. And I feel like it's just constant learning because there's a million different like program things that you could learn.
That's right. Yeah, there's a lot. There's a lot to it. So this episode, we're starting something new. So we haven't given up the book yet, but we've stopped the book because we're at a certain point where we can pivot and introduce new technology in order to be able to utilize and exercise the technology that we've learned in chapters 1 through 6, right?
Mhm.
And so in this episode, we're going to be covering databases. So I'll pose a question to you, Jonathan. What is a database?
To me, that just seems like something that stores information, like an address book, um, would be a simple thing, or something that, yeah, that you could just input values or different things. It could be numbers, um, just things that you could store.
When you say numbers, like phone numbers, you mean?
Yeah, phone numbers.
Yeah. Yeah. So databases have existed since, I want to say, ancient times, because the the whole the definition of a database is just being able to store information, like you said, like an address book, right? You can store birthdays, and we know that in ancient times they would store birthdays all the time on hieroglyphics, stuff like that. So in its purest form, that's really what a database is just storing information so that you can retrieve it later. In its digital form, though, the digital definition is it's a little bit more different, or I should say a lot of bit more different. um, in its digital form, there's all sorts of ways of storing databases. And I think like some of the first databases were like just plain text files. So if you open up Notepad, you and another developer would just agree, okay, columns 1 through 10, that's going to be our unique ID. And how do we generate that ID? We're going to go to the bottom of the file. We're going to look at that number and we're going to increment it by 1, and that's going to be our ID. And then columns 11 through 20, that's going to be like the first name. And 21 through 30, that's going to be the last name, so on and so forth. So you like literally would open up a file in a program and grab those column names and say, okay, here's the column names, and this represents our ID. The second column represents our full name or our first name, our last name, so on and so forth, right? And so, but then they started getting into like, okay, but we also need to store an address, but it doesn't fit the format. So then they would say, okay, fine. When we hit the first line with a particular like tag on the record, we know that that's going to be the name. The next line is going to be the address. And then the following line is going to be the phone number. And then the next line that has that same tag again, we know that's the next record. And that's the first name. And then the second line. So then they started like expanding it, right? But it was very clunky, and it was very difficult to be able to pull information, quickly. So I believe it was like late 80s, early 90s. I wasn't into computers at the time, but I have heard the story where a company by the name of Oracle and Microsoft came together, and they came up and they started designing a database. And the first one that they came up with was called, I think it was called SQL Server. At a certain point, Microsoft says, hey, we want to integrate the database more into the operating system. And Oracle said, okay, that's cool. We're not going to do that. We want to be able to run our databases on any operating system. So that's where the two companies kind of went away. Let me correct my story. And again, this is just like a story that I heard. I'm not even sure if it's 100% true. Oracle, Microsoft, and a company by the name of DB2. And so those are the three that started the database. And once Microsoft wanted to integrate their database into the operating system, Oracle and DB2 took their efforts and they went off on their own. So right now you have like a ton of databases, but the main players were SQL Server, Oracle, and DB2. SQL Server would run on Microsoft Windows, Oracle would run on Unix, and then DB2 would run on the IBM mainframe. And so they each had their own implementation and they kind of went their own ways. And eventually they became like strong competitors. And just depending on the hardware you had, if you had an IBM system, a mainframe system, then you would go and install DB2. If you had a Unix system or Linux system, then you would run Oracle. If you had Windows, you would run, SQL Server. Fundamentally, they were all the same. But what was different was that instead of having lines in a text file and saying, okay, the first line is the header record, the second line is the address, the third line is the phone number, they said, let's re-architect this and let's just create separate tables for this so that we only have name, address, and phone. And then we'll find a way to relate these tables so that we can go and pull for one user, we can go and pull the address and the phone, all together. So they came up with this programming language called structured query language, or they actually pronounced the acronym SQL. So it's spelled SQL, but it's pronounced SQL, and it means standard query language. And so this standard query language is, if you learn the ANSI standard, you can query databases from SQL, Oracle, Postgres, DB2. But so this was like a standard. So you learn the SQL syntax and you're able to query any database. You can even run SQL inside of Excel to query your data sheets, So it's a pretty powerful language, and the fact that they made it a standard made it so that you can go across the board. So there's that. But what we're going to do, we're actually going to break our segments into multiple segments. So this podcast is going to take a pause, and you may see a blip. I'm not sure how we're going to edit it, but we're going to install the database, and the database just takes a long time to download, a long time to install, and we don't want to bore anybody with that. So we're going to cut, install, and then we'll come back and we'll continue with our database segment. So if you want to watch the installation portion, and Jonathan, I'm sure we'll figure out a way to make it go quicker than it normally takes. You can, we'll put the link in the comments, I guess, and you can go watch that. So with that said, with the power of digital magic, we're going to install and we'll be back. The first thing we need to do is we need to create a database. So let's go ahead and expand databases. And there's nothing in there. It's an empty server. So let's right click on databases and new database. And let's give this a name. We'll call it address book. No spaces. Okay. Now, I'm not going to worry about where these files are saved, not now at least. So we'll go ahead and there's one more change that I want to do. And this is just to save you disk space. Let's go into options. And you see where it says recovery model, the second dropdown? We want to do simple. So here's the thing about databases. Databases are made to be foolproof and lose no data. That's their goal, is they don't want to lose any data. So the different steps that it takes in order to save the data is that until it's sure that that data is on your hard drive, it won't close the transaction. So even then, for the administrator, the the logs that it builds up don't get truncated until the database is backed up. So for any reason you need to go to a specific point in time, you can go to that specific point in time by using by restoring your database from backup and by rolling forward the or backwards the logs, and you can go to that specific point in time. For the learning purposes, we're going to use a simple model, which means that as soon as it saves it, it truncates the logs. Otherwise, your logs just keep growing and growing and growing, and eventually you just run out of space because we're not going to back up these databases. So switching it over to the simple model is the way to go if you're doing development and you're not going to back up the databases. Okay. So
All
go ahead,
right,
click OK.
there it
All
is.
right, we got our address book. Let's expand our address book, see what we got. We're going to focus on tables for now. So let's
Okay.
go and expand tables. And we're going to right click on tables and we're going to create a new table. So an address book, right? We can have all this different information, but we're going to keep it down to the basic. Just like we did our little console application where you asked the user for their name, their address, and their phone number. We're just going to ask for a name, okay?
Okay.
But one of the things that we need to do is we need to create a unique value for each row has to be unique. Okay. It doesn't mean that Jonathan Campos can't exist more than once in that table because you're not the only Jonathan Campos. But we do have to say what ID did that particular Jonathan get, right? And so the first one is normally you'll create a field that is a unique identifier. And for the most part, you want to make it the same name as the table. This is common practice. It doesn't have to be, but this is common practice. The name of this table is going to be called people. So because people and person it's not like you can say dog and dogs, right? Because you can create a table called dogs, and then you can create a field called dog ID, right? But the thing with people and person is that singular is person, multiple is people. We have to say person ID as far as the field name is concerned.
Okay.
So we're going to say person ID. Oh, it's no spaces, no spaces and camel case or Pascal case. Sorry. So if you move on to the next field, data type, what's going to be stored in here? So let's do the drop down. And in here, what we want to store is an integer. So let's go look for integer. There you go. And because we need to always have an integer in this field, we're not going to allow nulls. Okay, so before we move on to the next field, there's one other thing we need to do to this. If you look at your custom property or your column properties down at the bottom, go ahead and expand it up a little bit. You can open up that window. Okay, so go to the table designer. Now, you see where it says identity specification?
Mm-hmm.
We don't have to be responsible to create a new ID every time. SQL Server can do this for us, and it does it a lot better than we can ever do it. So go ahead and expand that. And we want to say that this is an identity field. So we want to go ahead and switch that no to a yes. It's a no, go down to is identity.
Oh.
And we don't want to allow nulls. Everybody has a name, whether you don't have a last name or a middle name, whatever, but you have a name.
Mm-hmm.
And what else do we want to collect about the person? Let's collect their age.
Each.
Or better yet, instead of an age, because the age is going to change every year, right? Let's collect their birth date. So we could do birth date. Yeah, birth date's fine. And that's going to be a date. Now, you could do date, you could do date time, which gives you the date time as well. Or you can do date time 2, which goes beyond a certain date, if you will. But date works perfectly fine because most people just provide a date and that's it. And because everybody was born at some point, we're not going to allow nulls. So this is information that we don't want to let people get away with not providing it. It's like, hey, you got to provide this. You can't insert a record without giving us your full name, whether it's just your first name or your first and last name or your first, middle, initial, and last name. But you got to give us something and your birth date. So that's kind of a way of enforcing rules, right? So that your data that you're entering into this table has some kind of integrity. Because if you allow nulls, people are just going to add records, empty records, and you're going to have all these IDs that are meaningless. You understand what I'm saying?
Yeah.
So let's go ahead and save this. And you do that by either Control S or by hitting the little disk right there. Yep. And we're going to give this a name. Let's call it people.
And we'll hit OK. And let's close this.
Just like this?
The little X.
Oh,
yeah, on the tab. Yep. And you could right click on tables and refresh.
Yep. Yes, we got our first table.
There it is.
So, a database is a collection of one or more tables. Okay. And then as we start learning more about this, we'll start getting into how multiple tables can be related and stuff like that. But we'll work with this for now. Let's right click on this. And let's go to edit top 200 rows. So you don't even have to enter an ID. SQL Server is going to do that for you. Just go ahead and start in full name. And put Donald Duck. Where's your respects for Donald Duck? Spell his name properly. Capital D. And then his birthday, we'll put it on, let's see. Let's just say that his birthday is June 3rd, 1964.
And then go ahead and press enter.
Whoa.
Cool. I was like, what? How should I write this? But it fixed it for me.
It knows what you want, Jonathan. Let's go ahead and enter. Let's go ahead and enter another one. What's another character that you want to put in there?
Mickey Mouse.
Mickey Mouse. And let's say that he was born. Okay, so now that's one way you can enter it. You see the format that they're using? Year, month, day. You can actually use the same format into the year 1963-01-22. Press enter. All right, and let's just add a third one just for kicks. And you see how it's generating the IDs for you? So the person ID, you can have another Mickey Mouse, but it's going to be ID 3 now. And that combination of all three columns is unique. And that's what that whole ID column is for, is to create a unique identifier. So go ahead and add another one of your favorites.
Okay.
Scooby-Doo. He was born in the 70s, 1977. And I want to say he's December. Somewhere on time around the 15th. Press enter. All right, cool. So let's close this up. And so that's kind of painful because if you have, so we have 3 records in there, but imagine you have 1 million records, okay? You can only edit the top 200. So you can't, if you have 1 million records, it's like, oh man, it's like, how do I grab the right 200, right? So what we're going to do is we're going to open up a new query. You see there's a, up on the toolbar right under window, it says new query.
Okay.
All right. And so in here, we're going to start using SQL, which is the structured query language. So this is the programming language that is used, okay? And so one of the most important things is a comment. How do I write a comment, right? And in SQL, you do a dash dash. The first keyword is select. So type in select and space, and we're going to say star or asterisk, capital 8, and then space. And now we're saying select everything or select all the columns from, so it's from, and you got to specify the table name. So in this case, we're going to specify people.
People.
Go ahead and you see under new query, there's execute. So go ahead and click on that execute.
Whoops. Oh no. There we go.
The first keyword is select. So type in select and space, and we're going to say star or asterisk, capital 8, and then space. And now we're saying select everything or select all the columns from, so it's from, and you got to specify the table name. So in this case, we're going to specify people.
People.
Go ahead and you see under new query, there's execute. So go ahead and click on that execute.
Whoops. Oh no. There we go.
And it brings up your records.
Mm-hmm.
This is read only. You can't modify it. Go ahead and copy that, and let's create a new one down below. So copy the whole thing, and then paste it right below. And then we're gonna get one record from the people table. So we're gonna continue on. Select star from people where.
Oh.
People spelled, oh yeah, okay. Where person ID equals 1. And then you can highlight that one line, and then press execute. And it only gets that first one.
Mm-hmm.
You can do the same thing, right? You could change it to 2, it'll get you number 2. Highlight it, or otherwise it'll run the whole thing. You can also do anything on the other fields. So you can actually select it based on a birth date on the full name. So you can say full name equals or birthday equals. They have to go inside of single quotes.
Okay.
So put no, not the birth date, but the value that you're going to put in. So single quotes. And then you have to type in the format exactly the way you see it down there. So 1963-01-22, and then close your single quote. And highlight and run it.
There it is.
Yep. Now, let's go ahead and copy that line and paste it right under. Yeah, you don't need an empty space. That's fine. Let's go ahead and search on the full name. You can press tab when it comes up. Yeah. And then inside of single quotes, you need to type in the name.
All right, highlight
it and run it.
Yeah.
Now, what if you didn't know the full name? Let's go ahead and copy that line and paste it right under. if you didn't know the full name and you're like, it's some kind of a mouse, I don't know his first name.
Mhm.
Instead of saying equals, well, if you do, go ahead and try to search for mouse.
Okay.
Nothing comes up.
Mm-hmm.
So instead of doing equal, you would do like. And then you would put inside around mouse, but inside the single quotes, you would put percent signs. The percent, not pound.
Oh. Both sides?
On both sides. Essentially, that indicates a wild card. Anywhere where mouse appears, bring it up.
Cool.
So it's a pretty powerful language, and
Yeah.
it does very fast searching, right? Do an insert. So this is add a comment. So this is inserting a new record. All right, so let's enter the insert command. It's insert into and then the table name, people. Now, what we have to do here is we have to specify what columns we want to insert into. Okay, so open up a parenthesis. And we don't have to insert into the person ID because that's generated for us automatically. So we want to insert the full name, comma, birthday. Okay, and then outside the parenthesis, you're going to indicate these are the values by using values. And then open up another parenthesis. And inside of single quotes, let's give it a name. What's another character?
Okay. Let's do Goofy.
Single quote, close the single quote. And then comma, his birthday. And the birthday goes inside of a single quote as well. All right, let's highlight it and execute it. One row was affected. Doesn't give you a whole lot of feedback. It's kind of primitive, isn't it?
Yeah. Even the text is kind of weird too.
It is. So let's go to that first line, select star from people, highlight that one. The first line up on top.
Okay.
Highlight that one and let's execute it. Look at that.
There it is.
Pretty nice. All right. Let's go to the next one. So this is going to be update the table, which is people. And then we're going to say set. And we got to specify every column because we're not going to update every column, but we have to specify what column we want to update. So let's just go ahead and set the full name.
Inside parentheses?
No, well, it's the column name, so not yet.
Oh.
Equals. Now you need it inside of single quotes. Let's change Donald to Donald D. Duck. D is his middle name.
Okay.
Middle initial. And then close your single quote. And then we have to specify, see, if you just run this right now, it's just going to say, okay, let me go update all of them with Donald D. Duck. So we have to specify a filter. And just like we specify a filter when we select, you use the same thing. You use a where clause. And we're going to specify that specific record. So we're going to use a person ID equals 1. So this limits the update to that one record where the ID is equal to 1. And we know that that column is unique, so it's only going to update one record ever. So go ahead and highlight and run it. One row was affected. Let's check it out.
Oh. There it is.
Nice. So we got our select, we got our insert, we have our update. Let's go ahead and do our delete. So this is going to be, the keyword is going to be delete. People. Where? I don't know. Person ID equals 4. So this is going to delete that one record. You can't specify what columns to delete because it just deletes the whole row. And let's, oh, one row was affected. Let's go ahead and select star.
There it is. It's gone.
Now, here's what is special about delete. Delete is unrecoverable. You can't, once it's gone, it's gone. It's not like a file where you can go undelete it. Inside of a table, when you execute that delete command, it is gone. There's no coming back from it. So what a lot of companies will do is they say, we don't want to delete anything. So what they do is they add a delete flag as a column. And it's just either deleted or not deleted. It's just yes or no, you know? And so instead of ever running the delete command, you just always run update. So that when you delete a record, you say, okay, let's just go update that one column to say, yes, it's deleted. But now you have to manage when you're displaying records that they've been deleted. And so it's kind of not the ideal way to go, but it's an option, you know. But yeah, a delete is unrecoverable. You cannot come back from a delete. You can't say, oh no, that wasn't the one I was supposed to do. I got to undelete. There's no undelete command. So this is kind of the basics of manipulating data.
Yes.
This is going to be the DB challenge. And it may be simple. I think you'll be able to do fine. Databases are very easy to pick up. And some of the advanced stuff is a little bit more tricky, but for some of this basic stuff, I feel like you've got it pretty well. So the first thing is we're gonna create. Actually, we'll put numbers here. Create a table named address. It should be plural, addresses. With the following structure. So we'll say address ID. It'll be an integer and no nulls. And then it's going to be a person ID. Oops. It'll be an integer. No nulls. So those are the two fields. The first one is the primary key, right? So, we got to also make it primary key. And then you also have to make it so that it increments automatically. Okay. The person ID is just going to be how that relates to the person table. So it's basically whose address does this belong to, right? And then we're just going to say line 1, and this is going to be a varchar. The default 50 is fine. No nulls. And it'll be city. And again, varchar, the default 50 is perfectly fine. State. What I want to do is I want to make this a car 2 because we only want the two, the two initials, and it's going to be no nulls. And then zip code. And zip code, we'll just take the first 5, so we'll do a car 5. No nulls. And then you're gonna insert records using the insert command. You're gonna select records using the select command. And then you're going to update records using the update command. And then you'll delete a record. Using the delete command. All right. So that's going to be your challenge for the week, is create the table. And I'll go ahead and copy this. I'm going to stop sharing. So you can go ahead and put that in the show notes.
Mm-hmm.
And that's going to be your challenge for us to review on episode 9.
All right.
And then next week, we'll expand into using these commands from C#. So we'll write a C# little program that'll connect and it'll allow us to do this from C# itself.
All right.
All right.
Fun.
And with that, I think we're done for the day. It's already dark in my room. I forgot to turn on my lights today. It's a good thing I got plenty of monitors to light me up here. All right. And
Yeah.
we'll see everybody on the next episode.
On the next
Road to Code. Yeah.
Let's do some coding.